Okay, so our next lesson on proportion and proportionality is working out proportion but using a more formal approach than we've been using so far. And there's terminology that we can use that relates to this, which describes it in a more formal way, which we've learnt with a lot of things along the way. So, the relationship of proportionality can be described in the following formal way. A is proportional to B. So see this little symbol? This is the symbol that describes proportionality. A is proportional to B does not mean that it's exactly the same as, does not mean that it's equal. It means that it's directly proportional. So remember that direct proportion means the two variables increase at the same rate. So they're each increasing at their same individual rate, which are not necessarily the same thing. So in proportion, the rate, which is what we've been working out what it increases at in a more informal way in our last lessons, is denoted by a K. K is known as the constant of proportionality. So remember I talked about that in the last few lessons. Constant of proportionality, that means how much the second variable is going up by. What is the rate that it's increasing at? Or in other words, whatever you multiply A by to get B. So once we add that constant of proportionality, you can actually change the sign of the equation. We don't need to use that directly proportional sign, and we can turn it into an equation we can solve. So adding the constant of proportionality makes the equation A equals K times B, because K is the constant of proportionality, or the rate, or how much the second variable is going up by, and we can use it to solve it. So let's have a look at an example. So if 30 kids need 120 grams of Milo, how much will 18 kids need if they are directly proportional? So let's solve this in a formal way. We know they're directly proportional, so let's see what we can do with it. So the first thing I'm going to do is define some variables I can use. So let M equal grams of Milo. I'm going to let S equal number of students or kids. And like I said before, I'm going to let K equal the constant of proportionality, because if I include that in my equation, it's going to be something I can solve without any problems. Constant of proportionality. So in this case, constant of proportionality is how many grams per student. That's what it's going to tell us. So we know that M is directly proportional to S. And we know that because it told us that in the question. So we also know if we add in the constant of proportionality, M is going to be equal to the constant of proportionality times S. And we know that because that's the rule that relates to direct proportionality. So now we've got it in an equation form, so we can actually substitute what we know and solve. So let's do that. So the first thing I want to do in this situation is find K. I don't know what that is. I've got 3 unknowns at the moment in my equation, and that's a problem. So let's substitute in what we do know to find the one unknown we don't know. We do know that M equals 120 and S equals 18. We know that from the question, so we can find, and we can substitute that rather into our equation, M equals KS. So let's do that. So that's going to become 120 equals K times 18. Rearrange 120 divided by 18, K equals 4. So now that we know that our constant of proportionality is 4, we can substitute that back into our equation here and have an equation that's only got 2 unknowns in it, which is more like what we've been doing. So we can rewrite our equation, M equals 4S. So that's 4 grams per student is going to tell us how much Milo we need. So second part of the equation will allow us now to answer that. So we want to find M, how many grams of Milo, if the number of students equals 18. That's what it told us in the question. So M equals 4S is the equation we're going to use now, which equals 4 times 18, which equals 72. And that's the answer to our question. 72 grams of Milo is needed for 18 students. So you can see it's exactly what we've been doing before, but written in a more formal way. And now that you know that, this is probably the best way for you to do it now that you understand about direct proportion and indirect proportion. So let's have a go at doing some indirect or inverse proportion using the similar type of formal approach as well. Okay, so just a reminder that inverse proportion or indirect proportion is as one variable increases, the other decreases. So like the equation we had before, which was A is directly proportional to B, this time we can write it as A is directly proportional to 1 over B. Because if you remember from when we did index laws, 1 over B is the inverse of B. So that means the minute you've got the equation like that, we're talking about inverse or indirect proportion. Now, just like we had before, we can change the sign to an equal sign if we add in the constant of proportionality, K. How much is the rate that it's decreasing? How much is that rate that our second variable is decreasing? So to do that, your equation is going to look like this. So A equals 1 over B times K. So all I've done is put a K in and change the equal sign here. And let's simplify that. So it's really K over 1. And as we know, multiply top by the top, bottom by bottom. So that's going to give us A equals KB. Any questions about that or you don't understand, please see me in class. So let's have a go using that to answer this problem. So the time taken to travel a certain distance of inversely proportional, proportionality, to the travelling speed, i.e. the faster you go, the less time it takes. At 100 kilometres an hour, it takes 2 hours to complete a journey. If roadworks limited the speed to 40 kilometres per hour, how long would it now take for the same journey? So obviously, this time one variable is changing, so we need to see what the difference is going to be. Okay. So again, the first thing I'm going to do is define some variables. So let's S equal the speed travelled. That would be a good place to start. Let T equals the time taken. And again, K is going to be my constant of proportionality. Okay. So write your equation. T is directly proportional to 1 over S because they are inversely proportional. It tells us that. So we can write this as T equals 1 over S times the constant of proportionality, which leads us to simplifying further, T equals K over S. So all of that is exactly the same as what you saw before. Same steps we're going to follow. First thing we're going to do is find K. What is my constant of proportionality? So if T equals K over S, we want to find K when T equals 2 hours, so that comes out of the question, and S equals 100. Speed is 100 kilometers per hour. So we can use that information to find our constant of proportionality. So let's sub in. So 2 equals K over 100. K equals 200. So we can put that into that equation. So this is going to give us T equals 200 over S. So this will tell us the equation that we can use to solve the question it's actually asking, which is how long is it going to be when the speed is only 40 kilometers an hour? So in other words, find T when S equals 40. So let's do that now. So T equals 200 over S. Sub in what we know, which don't know T, we're trying to find it, so it becomes 200 over 4, which of course is 5. So there's our answer. It would take approximately 5 hours. Now it's never going to be 100% accurate, it's only going to be an approximate at 40 kilometers an hour. Lots of variables in there that could change that slightly. So hopefully that makes sense. You can see it's the same process as the first one, just the formula we're working with is different. Now, one last little thing I wanted to show you. So it is possible to be directly proportional, directly or indirectly, to values such as a square, a cube, a square root, or any other function of a number. Any of that is just a number. It's just got an extra function attached to it. So when you've got that situation, you must use this formal approach using the formulas I showed you to be able to solve it. So you can't use it in a simple way like we did for the first couple of lessons. You must use this more formal approach. Let's have a go at this question. So a stone is dropped from a high tower. The distance it falls is proportional to the square of the time of the fall. Now, it doesn't say if it's direct or indirect, and it doesn't matter. You just know it's proportional. So you can use this information to solve it. The stone falls 19.6 after 2 seconds. How far does it fall? Ooh, more typos. After 3 seconds. Now, if we have a think about it, the faster it falls, the further it falls, the more time it's fallen, the more distance it's going to be fallen. So if we think about it, it's going to be directly proportional here. Both of them are going to be increasing. But before we do any of that, let us write our variables. So we're going to let d equal the distance fallen. We're going to let t equal the time taken to fall. And we are going to again let k equal our constant of proportionality. Now let's write an equation based on what we know. Now we've decided it's direct proportionality. So in other words, we've got y equals kx. So it doesn't, or a equals kb. So in this case, our distance is going to equal our constant of proportionality times the square of the time taken it to fall. So the time taken is t, but we want the square of that. So you can see we've actually got a square in this equation, which is no problems. It's just that you have to do it in this way. So same process as what we did before. So when d equals 19.6, which comes from the question, and t equals 2, let's find k. So we can simplify our equation. So 19.6 equals k times 2 squared. 19.6, of course, then equals 4k. K equals 4.9. So we can rewrite our equation, d equals 4.9 t squared. Now it's a lot simpler, so we can actually solve the question. How far does it fall after 3 seconds? Whoa. So when t equals 3, d is going to equal 4.9 times 3 squared. So we've just subbed into our equation, d equals 44.1. So that's how far it will have fallen after 3 seconds. So write a sentence. In 3 seconds, the stone had fallen 44.1 meters. Okay, so again, nothing much in the textbook here. So there's some questions here that you need to do. Complete these questions. Use the formal approach for both direct or indirect proportion. Now, you don't have to do all of them. You just need to pick any 7, but make sure at least 2 of the questions include something that includes a square or a square root. So you're doing a couple more difficult ones. Solutions are available on here also. And the homework for the next lesson is revised for the diagnostic test. So this is your last lesson before that. Before the lesson after that, you need to watch the next screencast. All right, see you in class.